Okay, let's record here. Okay, I'm recording now. Okay, so let's take one example, okay, as a tutorial. So for example, if you have this data, so you have the different activities, you show the activities by their, if you have activities like A, B, C, D, E, F, and G. Can you hear me?
Yes.
Okay, so for each activity, we also know the preceding activity. Okay, so immediately preceding activity, immediately preceding activity. So for A, there is no immediately preceding activity. For B, A, for C, A, and then for D, it is B. For E, it is B and C, and C, and then for G, it is D, E, and F are three immediately preceding activities. Okay, and then you also know the duration. Okay, so duration for each activity. So duration of each activity is 5, 8, 6, 9, 6, 3, 1. 5, 8, 6, 9, 6, 3, 1. Okay, so now our task is to draw the project network. Okay, so suppose if we have a project in which we have activities A, B, C, D, E, F, and G. Okay, and we also, for each activity, we know that immediately there are certain activities are preceding. So for example, for B, there will be an immediately preceding activity that will be A, and for C, it will be also A, for D, it will be B, etc. And for each activity, we have also estimated the duration of the activity. So if we have this information, then can we draw the project network? So we will draw the project network. So we have two approaches. So one is the activity on network approach, activity on node approach, okay, activity on node, AON approach. And the other is the activity on arrow approach. So we will do the activity on node approach first, okay, to draw this project network. So for activity on node approach, I will represent the activity by this some squares, okay. I will represent these activities with these squares. So I will start from activity A, okay, activity A I will represent by this. And then I will put A over here, and then its duration 5 here. And then after A, because for this A, I know that there is no immediately preceding activity. So this is the starting activity of the project. Okay, so if for any activity, if there is no immediately preceding activity, that is the starting activity of the project. Next, after A, I can see that there are activities B and E, C, who both have A as their immediately preceding activities. So in the activity on node network, their precedence relationships are represented by the arrows. So we will, I will draw activity B somewhere here, and then I will draw activity C here, and maybe I can show their durations as well, 8 and 6 over here. And then from there, I can connect them with the arrows. So these arrows show the precedence relationships. So from the finish of activity A to the start of activity B, finish to start relationships. Here we don't mention the type of relationship. If it is not mentioned, then it is always understood that the relationship is a finish to start relationship. Next, we will draw D. So D has a immediately preceding activity as B. So therefore I will put D's here. Okay, and immediately preceding activity as D. So the duration of D is 9. And for E, there are two immediately preceding activities, B and C, B and C. So for E, there are two immediately preceding activities. I will put E over here, and then I will draw an arrow from B to E, and then from C to E. Okay. So this will show that E has two immediately preceding activities. So E has 6 as the duration. Okay. Next, there is F. F has only C. So F has only C. So F I will be, maybe I will put F over here. And it has C as the immediately preceding activity. Okay. And then it has a duration of 3. And then last activity is G, which has D, E, and F. So D, E, and F. So maybe I can put G over here with 1 day duration. And then there is a relationship from D to G, from E to G, and from F to G. Okay. So in this way, we have drawn this network. So it is always a good practice to check the logic of this network diagram once you have drawn, so that you can be sure that you have not made a mistake. So you can check for each activity. So from this network, I can see that G has 3 immediately preceding activities, D, E, and F. So D, E, and F. So, for D, I can see it has 1 immediately preceding activity as B. D has B. E, there are 2 immediately preceding activities, D and C. Okay. So similarly, you can check for each activity whether you have whether that logic which is given by these immediately preceding activities in this table is shown in this network or not. Okay. So after this, then we will perform the network calculations. Okay. So for network calculations, we need to calculate the early start time, okay, early finish time, late start time, late finish time. Okay. So these we need to show it on the diagram. So therefore, as I have just drawn this diagram by hand, so I did not draw it in a more proper formatted way. So more proper formatted way is something like this. Okay. So in which you have this kind of format. Okay. Right. So here you have the early start time, early finish time. So anyway, we can represent these times over here. So for these networks, so we will start from 0. For manual calculations, we will start from 0. That means we are starting from here. And then this is the early start time of activity A. So early finish time, from the early start time of activity, then we will move to the early finish time. That means we will add the duration and then we will get the early finish time. So 0 plus 5 will be 5. Okay. So once you have done it, done for that activity, then you will not move like here. You will move to the next activity. Okay. So the next activity is 5. So if activity A finishes on 5, then we can put the start of this activity B as also 5. But in reality, because we will put these 5 and 5 numbers for our convenience. Okay. Because it gives us more convenience in doing the manual calculations. But in reality, if it is 5, that means if it is finishing on Sunday, if this work is finishing on Sunday, the next activity will start on Monday. That means if Sunday is the 5th day, then it will start on the 6th day. So it should be 6 over here. But for our convenience in the calculation, we will just put it as like 5. So it will mean that it is the end of day 5. End of day 5 is the start of day 6. Okay. End of day 5 is equal to the start of day 6. But anyway, we will go like this in this manner. So if it is 5 now, so 5 plus 8 is 13. So that will be the early finish time. Here it will be. Now tell me this value.
Which value?
Yeah, here for C. So it may, can you see this cursor, like this arrow, which when I move, or you just only see when I do something?
There is no.
No, we don't see.
I see. Yeah, this is the problem because I'm using the Microsoft Word. So when I only write something, then only you can see. So this is the problem, because right now my cursor is on activity C, and I wanted this value. So for example, here 5, I wanted this. So then 5 plus 6, it will be 11. Okay. Okay. Yeah, I think there should be some option that my cursor should also show over here, wherever. Anyway. Okay, so this is the one. And next is for activity D. For activity D, it should be 13 over here, right? And 13 plus 9 is 22. For activity E, now I am at activity E. For activity E, can you tell me what will be the value?
13.
13, yes. And 13 plus 6, it will be 19, okay? And for activity F, what will be the value?
11.
11. 11 plus 3, it will be 14. So now we have already completed D, E, and F. Only activity G is completed. So for activity G, what will be the value over here for early start?
22.
22. And 22 plus 1, it will be 23. Okay, so in this way, we have completed the forward pass. So we have completed the forward pass. So what does the forward pass tells? Forward pass tells us the early start, early finish time of each activity, and also it tells the duration of the project, duration of project. Okay, so this tells us. So the duration of the project in this case is 23. So now we will do the backward pass. Okay, backward pass. So in the backward pass, I have 23. 23 minus 1, it will be 22. Okay, so this will, in this way, from here, we will move to this point. So only at this point, we will connect the early finish time of the activity with the late finish time of the activity. And that activity is that activity which is the, for which there is no immediately succeeding activity. Okay, that is the last activity of the project. If there are more than last activities, more than one last activities of the project, then you will put a finishing milestone, and then from finishing milestone you will move backward. Okay, so it will be 22. So from 22 we will move to activity F. It will be 22 over here. 22 minus 3, it will be 90. And then I will move to activity E. For activity E, it will be 22 over here. 22 minus 6, it will be 16. So now the late start time of activity E is 16, and then late finish time is 22. And then we will move to activity D. It will be, it is activity D, it is. What will be what will be for activity?
Same 22.
Okay, so activity D, it will be 22. Okay, 22 minus 9 is 13. Okay, and then now I will move to activity B. So activity B, can you tell me what will be the value?
13.
13, yes. So 13, and then the other value is 16, so it will be 13. And 13 minus 8 is?
5.
5, okay. And for activity C,
16.
yeah, it will be 16. One will be 16, it will be, and the other will be 19. So I will take 16. So 16 minus 6, it will be 10. So it will be 10. Okay. Okay, so now for activity A, it will be 5, and then 5 minus 5 is 0. Okay. So in this way, we have completed the backward pass. So in the backward pass, what we have calculated the late start time and the late finish time. And in addition, by the backward pass, we will calculate the total float of each activity. So what is the total float? Total float is the difference between the late start and early start, or it is also it can also be calculated as the late finish minus early finish. Okay, or in another word, it can also be calculated as late finish minus early start minus the duration of the activity. Okay, so any of the three formulas can be calculated. So we can now calculate the total float of each activity. So the total float of activity A, maybe I can show it here. Okay, on here in this path on here. So total float of activity A will be 0. Total float of activity B is 0. Total float of activity C is 5. And total float of activity D is 0. Total float of activity E is
3.
3. And total float of activity F is 8. And total float of activity G is 0. Okay, so this is the total float. So in this way, we have completed this table. So once you complete this calculations, you can draw a table. Okay, you can draw a table. So for example, if I want to draw this table, I will draw some horizontal lines and vertical lines. So activity A, B, C, D, E, F, and G. And then the duration of the activity, duration of the activity is 5, 8, 6, 9, 6, 3, 1. And then some more columns. So these columns are early start, early finish, late start, late finish, and the total float. Okay, and then you can just fill in these values. So for example, for activity E, what value we will fill? 0, 5, 0, 5. Okay, and total float will be 0. For activity B, what value we will fill? Can you tell me?
5, 13.
13.
Yes,
0.
5, 13, 5, 13, and 0. And for activity C, you will fill 5, 11, 10, 16, and 10 minus 5 is 5, right? Yes, so it will be, total float will be 5. And similarly, you can fill all the other values. So in this way, the calculations for the activity on node network method. So by the backward pass, you will also determine the critical activities, okay, or the critical path. So by the backward pass, you can also find the critical path. So the critical path in this network is that path which has a total float of 0. So the critical path in this is A to B to D to G. Okay, A, B, D, G. So this is the critical path. So you can show it like this. Okay, so this is the critical activity. So I am showing it with the red. Okay, critical activity, D and G. So these are the critical activities, A, B, D, G. Okay, and their relationships lines are also shown by the red arrow. So you can show this critical path on this network. So A, B, D, G is the critical path. And on this critical path, if you see that, if you take the duration of this critical activities over here, so the duration of A was 5, for B it was 8, for D it was 9, and for G it was 1. So if I add it, 5 plus 8, 13 plus 9, so it will be 23. So this means that the sum of the duration of the activities on the critical path is equal to the duration of the project. So the duration of the project is equal to sum of the duration of the critical activities. Okay, so this is one observation we have found over here. Okay. So the other activities C, E, and F are non-critical activities which have their floats. So the meaning of these non-critical activities is that these activities can be delayed without delaying the duration of the project. But the critical path, the activities on the critical path, if they are delayed, then the project will also delay. So for example, if this activity, for example, if this activity D, if this activity D is, instead of starting at 13, it starts at 15. Okay. So if it starts at, say, 15, so then I have written it 15 over here. 15 plus 9, it will be 24. And then the next activity will also start at 24, and then it will finish at 25. So the project will be delayed by 2 time intervals if I delay any of these activities on this. So delay on the critical activity will delay the project. So delay on of critical activity delays project. Okay. On the other hand, if there is a delay in the non-critical activity, and then that delay is within their total float, it will not delay the project. So for example, if I take, say, activity C, if activity C, instead of starting at 5, it starts at 7. So I will write 7 over here, 7, and then 7 plus 6, it will be 13. The new time will be 13. Okay. So since the new time is 13, so the next activity is here. It is already at 13. Okay. It is already at 13. So it is not going to affect the next activity. And then the following network node will not be affected, and the project is going to finish on 13 days. So delay on the critical activity, it will not delay the project. If instead, for example, if I use the total float of activity C, okay. If I use the total float of activity C, then what is going to happen? Okay. So for example, if I use the total float of activity C, that means instead of activity C starting at 5, it starts at 10. So maybe I can write 10 over here. So 10 plus 6, it will be 16. Okay. And then it is going to delay this next activity, but this next activity is also a non-critical activity. So if it is starting at 16, then the next activity is going to start at 16. 16 plus 16, it will be 22. But 22 is already 22 from here, it's already there. So this means that it is not going to delay the project. Okay. So if we delay the activity within their total float, it is not going to delay the project. But in any way, in this second example, we have seen that although we have delayed this activity C, but it caused the delay in activity E as well. Okay. But overall, the project was not delayed. Okay. So therefore, the total float on certain activities can delay the other activities, which means that the delay in certain non-critical activities can delay some other activities, but it is not going to delay the overall project. So just like in this example we have seen over here, when we delayed activity C by 5 days.
I have a question.
Do you want any question? Do you want to ask any question?
Yes. My question is, for example, if can non-critical activity become critical activity? For example, if
Yes.
it will.
Yes. If for a non-critical activity, so for example, if this activity E, now let me write again. Okay. So for example, this activity E can become a critical activity. For example, if it's preceding activity C, if I start from say day 10, if instead of 5, it is starting at day 10, then it will finish at 16, and then it will also cause the activity E to start at day 16. Okay, so now activity E will become a critical activity because its late finish time, late start time is also 16. Okay.
Okay. And then
So as a
we will have 2 critical paths, yes?
in that case, we can have more than 1 critical path, 2 critical paths. So as a result of changes in the project, non-critical activities can become critical activities. And it is not necessary to have only 1 critical path. A project network may have more than 1 critical path as well. So critical paths can be more than 1. Okay. So a non-critical activity can become critical as a result of changes in the project, and a network can have more than 1 critical paths. Okay, more than 1 critical paths. Okay, so that is for this example. Is it okay?
What does mean like TF?
TF is the TL is for total float, and it is the amount of time an activity can be delayed without delaying the overall duration of the project.
Okay.
TF is the total float. Okay, total float. Okay. Okay, so now let's do the same example with the activity on arrow diagramming approach. So I will share, and this time I will try this whiteboard. So can you see this whiteboard?
Yes.
Yes.
Okay, so can you see the cursor also now?
Yes.
Yeah, I think this will be much better. So for example, if I have the same project, A, B, I think the writing is also much better over here. A, B, C, D, E, F, G. So now you can see where I am writing and where I am now, right? So where is my cursor now on the screen?
In the center.
Yeah, in the center. Yeah, that's good, because earlier you could not see it, but now it's much better. Okay, A and A. So this is the activity, and this is IPA. IPA is the short for immediately preceding activity, and then this is the duration. Okay, A, I will draw the same net by the activity on arrow approach. Okay, B, comma C, C, D, E, and F. And the durations are same. I'm using the same data, 586, 586, 9, 6, 3, and 1. Okay. So now I will draw by the activity on arrow, AOA network. Okay. So for activity on arrow network, okay, so this is a little bit complicated than the activity on node network. So that's why for most current software and most current planners, they use the activity on node network. But anyway, so we will start from activity A. So activities are now represented by the arrows. Okay. So it's starting event and it's finishing event. Okay. Activity A. And then there is activity B. So after B, there will be activity A, there will be activity B. Okay. Okay, and then there will be activity C. So here you can see that now the are we maintaining the logic? B has a preceding activity as A. A has no preceding activity. C has a preceding activity as A. Okay. Next we have this activity D. Okay. So activity D. So activity D. So D has a preceding activity as B. Okay. Up to now we are maintaining the logic. Next we will have activity E, but E has B and C as the preceding activities. Okay. So therefore I will have this activity E over here. And okay, activity E over here. And now it has B and C as the preceding activities. Okay. So what I will do, I will draw a dummy activity from B from here and then from here to here. Okay. So this will show that E has B and C as two preceding activities. Okay. And then F has only C as the preceding activity. So I can draw F from here, F here. Okay. And then D. Yes.
Can we draw only one dummy instead of two? For example,
From here?
Yeah, just take the. I'm sorry. Okay, I got it.
Yeah. Yes, we can. You can try it, but I think it will be difficult to maintain the logic over here, because if I will just start it from here, so then E will have C and B. But in that case, because this dummy activity will then connect with E as well, so then F will also have B and C as the preceding activities. So it will be difficult to maintain the logic in this case. Okay. So next we have G. So G I can draw. So for this I need to draw this and this. These two dummy activities. So in this way, I will have G which has D as the preceding activity, E as the preceding activity, and F as the preceding activity. So in this case, yeah, what I can do is I can reduce this dummy activity by
Couldn't we just draw the activity D and F till the event of starting event of G?
yes. So yes, that's correct. So what we can do over here is, let me correct it. So because in this way, you will not draw first time in the correct way. After you will draw it, then you can make a correction. Okay. So that's why you should draw it with some pencil so that you can erase it and then, yeah. So erase, I will use this eraser now over here to correct. So it like this. So let me see. So now I can do, sorry. Right. So this is D and this is F. Right. So in this way, we just need to have only two dummy activities over here. Okay. So you can see that now is the logic correct? So D has, G has D, E, and F. Okay. E has B and C and nothing else, right? D has B and C has A and F has C. So I think the logic is correct now. Okay. So after that, now you can, we can.
Professor, can I ask a question?
Yes.
Why do we need this another type like activity and on arrow if we have activity on N and I just forgot like
Yes.
network maybe. Yes. Why do we need AOA? If we have
Actually,
AON?
yeah, actually you don't need it. I am just showing the process. And as I have also said that most computer programs and in most modern ways, activity on node network is also used. So I will do this example just once and then that's it. So for most of the cases, you can use the activity on arrow, activity on node network diagrams.
So Professor, I'm asking this because I just noticed that like activity on node is more like convenient.
Of course, of course. It's more convenient, yes.
Okay.
It's more convenient, but let's do this one so that you know both methods, okay? Okay, so for activity A, which is 5, activity B, the duration is 8, C is 6, D is 9, E is 6, and F is 3, G is 1. Okay, and then once we can do it, then we will be very much confident in our ability to do this in both ways. Anyway, so we will similarly we will perform the forward and the backward pass. So it will be 0, 0 plus 5. It will be 5. Right, and then 5 plus 8, it will be 13. 5 plus 6, it will be 11. So remember that we are now calculating the event times, okay? And then if it is 13, then it will be 13 over here, and from here it will be 11. So we will take 13, right? So from 13 here, from 11 here, so we will take 13. And 13 plus 9, it will be 22. 13 plus 6, it will be 19, and 11 plus 3, it will be 14. So out of these three values, we will take the higher value, and then it will be 23. Okay. So after that, we will do the backward pass. So 23, it will be 23. 23 minus 1, it will be 22. Okay. And what? Yeah, 22. So 22 minus 3, it will be 19. And 22 minus 6, it will be 16. So, but we will not take 19 over here. We will take, because one arrow is coming from here, another arrow is coming from here. So we will take 16. Here. Okay. So 22 minus 6 is 16. 22 minus 3 is 19. So this from 6, this 16 will come from here. And then from here, it will be 16 minus, yeah, it will be 16, right? And then it will be 16 minus 8, it will be 8, and 16 minus 6, it will be 10. So we will take
No, we should take 13.
yeah, I think here it should be, we should take 13. Yeah, because I forgot to take care of. So we'll take it. So 22 minus 9 is, it will be 13. And then from here it will be 16. So out of 13 and 16, it will be, I will take 13. Okay. Yeah, this was my mistake. And then it will be 5 and then 0. Okay, so in this way you have calculated the forward and the backward pass, and then we can complete the table. So for example, for activity A, and we will have this, we can complete this table, okay? And then the duration, okay. Activity. Early start, early finish, late start, late finish. So in this way, we don't get these pair of values for each activities directly. Okay. So for activity A, we will choose these values, this one and this one. Okay. So for activity B, we will choose these values, the opposite values. And for every activity, we will choose these opposite values. And then later on, we will fill these values. So the duration over here, it was 5, 8, 6, 9, 5, 8, 6, 9, and then 6, and then so on. So for activity A, we will take these values. Okay, and yes, so what we have over here is 0 and then 5. Okay, 0 and 5. And for activity B, we have 5 and 13. So 5 and then 13. Okay. And for activity C, we will have 5 and 16. Okay, 5 and 16. And then for activity D, we will have 13 and 22. So we will take this value and this opposite side. So early start and late finish values. Early start and late finish values for each activity. So for activity E, you will have 13 and 22. 13 and 22. So the early finish time will be 0 plus 5. It will be 5. 5 plus 8, 13. 6 plus 5 is 11. And 13 plus 9 is 22. 13 plus 6, it will be 22. And the late start time will be 5 minus 5, 0. 13 minus 8, 5. 16 minus 6, it will be 10. 12 minus 9, it will be 22 minus 9, it will be 32. 22 minus 6, it will be 16. And so on. So in this way, you will complete the table. And then from there, you can calculate also the total float by just subtracting 5 minus, early start minus late start. So 0 minus 0, it will be 0. 5 minus 5, it will be 0. 10 minus 5, it will be 5. And so on, you can calculate the total float. So is it clear, the calculations over here? Hello? Can you hear me?
Yes, we hear.
Yes,
you.
yes.
Yeah. So is this process clear?
Yes, yes, it is.
Yeah. So in the activity on arrow diagram, so network. Okay. So first draw the network. Maintain logic. Okay. Maintaining the logic. Okay. Maintaining the logic. Maybe you have to draw. That means draw and redraw. Okay. To reduce the redundancies. Okay. So for example, first time you may draw and then you may make some error, but then you can remove those redundancies. Remove unnecessary dummy activities, or remove wrong logic. Okay. So therefore, there's some trial and error will be done. And then perform the forward pass. Perform and backward pass. Okay. So this forward pass and backward pass will give you the activity times. Okay. Activity time. So early start time will be the early start of the event, okay, of which the activity is meeting. So for example, early start time of activity A will be the early start time of this starting event. And then we will calculate the late finish. That will be the late finish of finishing event, okay. That means from this diagram, you will take for each activities the opposite values. Okay. So for activity B, you will take these two values. Okay. So for activity C, you will take this value and this value. Okay. So opposing values you will take, and then these opposing values you will fill in these two columns first. Okay. And from these two columns, then you will add duration to this, then you will calculate the early finish time. And from latest finish, you will subtract the duration, then you will get the latest start time. Okay. And the total float you can calculate from by the formula, like late start minus early start, or late finish minus early finish. So in this way, the process will be completed. Does it make clear?
Yeah, the last thing about the comparison of event and so comparison of calculations about activity and event. So early start of activity.
Yes.
Early start of event can be taken as early start of activity, but late finish for activity. So doesn't.
Yes. Yes, so let me draw again. So this is the activity on arrow diagram, okay? And then this is the duration D. And then this is the starting event, this is the finishing event, okay? So, and for this event, so we have calculated the early start, early finish, okay? And late start, late finish. So from the arrow network diagram, the early start of A will be this one, okay, for activity A. And the late finish of A will be this late finish of this event, okay. And for the next activity, for
Yes.
example, if there is activity B, so this late start will become early start for B. For B, it will be the early start, and then therefore that will be the late start, late finish, okay. So we will go activity by activity. Okay.
It's not, I'm saying about what you have written over there underneath.
Yeah, you got my point, right?
Yeah, what I'm asking about the note that you have written.
Well, okay. Where it is? Maybe I made some mistake? Can you tell me?
So can you elaborate the second thing? So activity ES, that's clear, okay. Late finish and equal to early finish of event.
Activity early start is the early start of the event.
Yes, okay.
Activity late finish is the late finish of the event. Okay.
So you've written early finish, I didn't understand. Okay.
Yeah, okay. Late finish. Okay. Late finish of the finish event. Okay. All right. Okay, so this was the example for the activity on arrow diagram. And then I think you can see that it's a little bit inconvenient. So you have the choice. So you can use the activity on arrow network or activity on node network. Anyway, so that was the activity on arrow. So let's take some more example involving the precedence network, okay? So in the precedence network, you have the start to start and finish to finish relationships also, okay? So suppose if we have activities, 3 activities or maybe 4 activities you can take, okay? So for example, if we have activity A and then we have activity B, we have activity C, activity D, they are connected with the start to start and finish to finish relationships, okay? But let's draw their durations as well. I don't know, maybe 5, 3, 7, 4, okay? And activity A and B has the start to start relationships. So here you can see that how I'm connecting these arrows, start to start relations. So start of activity A is and the start of activity B with a lag of 1 day. And activity B has a start to start and finish to finish relationship with a lag of say 2 days. And similarly, start to start from C to D is with the lag of 3 days. Similarly, activity B and C can have the finish.
Showing finish to start. So what's the meaning of those last 2 arrows? You're just drawing finish to start?
No, start to start.
Or it's not start to start, but
It is finish to start.
yes.
Yeah, but what I mean is start to start. So I should make the correction. Yes, I should make the correction. So it is the start. Yes, start to start.
Professor, can you repeat what does mean 5, 3, 7, and 4? Is it duration?
These are the durations.
And 1, 2, 3, it is like lag. Oh.
These are the lags. Yes.
So it means that activity B should start 1 week or 1 day after start of activity A, yes?
Correct.
Okay.
Okay. So suppose if we have this kind of relationships over here, we are just including the start to start. So how we can perform the calculations? So we will start from 0, and 0 plus 5, it will be 5. But here now between A and B, there is a start to start relationship. So if it is 5, if it is 0, it is starting at 0, then it will start at 1. Okay. And then it will finish at 4 in this case. Okay. And what else? So for C, what will be the starting point?
3.
Yeah. So C, it will be 1 plus 2, it is 3, and then finishing at 10. And then for D, it will be
6.
6, and then it will be 10. So here you can see that how the finish activities will be starting. So activity A will start at 0 and finish at 5. So activity A will finish at 5. Okay. Activity B will start at 1 and finish at 4. So activity B will be like this, okay, at finishing at 4. And activity, so this is 5, this is 4. And activity C is starting at 3 and finishing at 10. Okay, so this is activity 10, C. So this is 10. So A, B, C, and then activity D will starting at 6 and finishing at 10. So activity D will be here. Okay. So in this way, the activities will be scheduled. So if in addition, if we have these activities and we have the finish to finish relationships as well. So for example, over here, if I use the same data, and start to start, and now in addition, I have the finish to finish constraints as well. Finish to finish, no, this is not finish to finish. If I have the finish to finish, well, you can have on all activities, or you can have on a few activities. So that doesn't matter. Okay, so if we have the finish to finish constraints as well, so same data I have used. A is 5, B is 3, and C is 7, D is 4, and then 1, 2, 3. And then for finish to finish, I just put no lag. Okay, but anyway, you can also put some lag as well. So now how the calculations will go. Okay, so this will make it a little bit complicated. Okay, so we will start from 0, and then 0 plus 5, it will be 5. Okay, and then for this activity B, okay, so we can go, I think we can also perform the backward pass calculations as well. So let's complete this first, the first one. I think we did not complete the backward pass calculations. Okay, yeah, okay, let's do this first. Okay, so we did it like this. So I think here we have this 10, 10, and 4. So 10 minus 4, it will be 6. Okay, and then from here, from this 6, so from here, if we will go from this 6, then 6 minus 3, it will be 3. Okay, and 3 plus 7 is 10. Okay, so it will be like that. Okay, and then from here, I have this 3 minus 3, it will be, sorry, 3 minus 2, it will be 3 minus 2, it will be 1, and 1 plus 3, it will be 4. Okay, and then from here it is it was 1, so 1 minus 1, it will be 0, 0 plus 5, it will be 5. So here you can see that their early start and late finish times will be like that. But I think there is something which we can which we need to change over here. So it is about can we change it from here? Because from, yeah, I think we cannot change from here. Let me draw it well over here. Okay. And then it was 1. So for suppose if it is going to start at 1 and then finish at 4, so it is not going to delay it. So for example, can we make can we make it as 5? So for example, if that 4, can we make it 5?
No.
Yeah. The reason is if it is 5, then 5 minus 3 is 2, and 2 plus 2 is 4. So this means that this will delay this activity. So or the overall project will be delayed. So I think in this case, there is no float in any activity over here in this case.
Professor, I think it will always happen like the same situation if there is only one pass.
No, not always. It will depend on the values. If you will change the values, the path or the late start or early finish time may also be changed. Okay.
Okay.
Here we are assuming that there will be a continuous work on this activity A. That means once we start this activity, then you will finish it after 5 days. You cannot have a break and then finish certain part of the work after some time. Although it can happen, but we are assuming that we are assuming a continuous work. Okay, so next do this example over here. So here we are using only the start to start only. Here we are using the start to start plus finish to finish. Okay. Start to start. Okay. So here we have this. Okay. So for the finish to finish relationship, I did not put the lag, just there is a relationship. So if it is 0, then it is 5. And then from here, I will move to this activity. But remember that for this activity B, there are 2 arrows coming into that activity, one at the finish and the other is at the start. So therefore, there will be 2 pairs of values. So from the finish, I will have, if it is 5, then it is 5. Okay, so it will be, the value will be 5. And from the start, if it is 0, then it will be 1. Right? Then it will be 1 over here. And 1 plus 3, it will be 4. So from 5 and 4, what value we will take?
5?
Yeah, we will take 5. So this 5 value is coming from the finish. This 4 value is coming from the start to start relationship. Okay, so we will take 5.
But Professor, why should we prefer like finish to finish rather than start to start?
Because finish to finish is giving us the higher value over here. So remember that 5 and then 4. Okay, so for example, if we will take 4, then this activity cannot finish at 4 because activity A has finished at 5. Activity B will only finish when activity A will finish. Okay.
But
So-
Professor, activity B should start 1 day later than the start.
One day, and it can start 1 day later, or it can start 2 days later, but
Okay,
not before 1 day later. Okay. So if it is 5,
okay.
then 5 minus 3, we will take 2 value over here. So this 2 value over here is not against the logic of this. So if it is 0, then it is 1. From 0, if you get 1, that does not mean that it exactly have to start 1. It means that it can start not earlier than 1, but it can start after 1. So that's why we will take 2 over here. Okay. So as we have checked. So again, let's do the same thing over here. So for C, now there are 2 arrows coming into this activity C. So from the finish to finish, it was 5. Okay. And from start to start, it is 2 plus 2 is 4, and 4 plus 7 is 11. So which value we will take? Five or 11?
11.
So we will take the higher value, 11 value. So we will take the 11 value as 11. Okay. So 11 minus 7 is 4. Okay. So we can check it that 2 plus 2 is 4. Okay, that is fine. And 2 plus 2 is 4. Okay. And then 4 plus 7 is 11. And then this 11 minus 11 is after that 5. So that is correct. Okay. So it is now 5, 4, and 11 now. Okay. For this, now what will be the value? So from the finish to finish, it is 11. Okay. And from the start, 4 plus 3 is 7. 7 plus 4 is 11. So both are 11. So we will take 11. So 11 minus 4 is 7 over here. Okay. So 7, 11, and 4. So in this case, by inputting the finish to finish relationship in the same network as we have done before, the project is going to finish on 11 because activity B before was 3 days, but it cannot finish before activity A. So that has caused a delay of 1 time unit. Okay. So these are the early start and early finish times, and the late start and late finish time will be, so from 11 we will go 11 over here. Okay. 11 minus 4 is 7. Okay. So from here, now we will go to this. So there are now 2 arrows. So 1 arrow is coming from the start. So 7 minus 3 is 4. And the other arrow is coming from the finish. So it is, if it is 11, so it should be 11 over here from this 11. So from this 11, it should be 11 over here. 11 minus 7 is 4. So it's the same value, 4 and 4. So we will take the both values. So 4 plus 7 is 11.
So, yeah, we take the last start of the last start of D and put it as the last start of C.
Yes.
As
Yes.
first option, and the second option goes from.
Yes. So the one option is this. Okay. One option is coming through this 11. 11 minus 7 is 4. Okay. And the other option is from this start to start 7 minus 3 is 4. 4 plus 7 is 11. So both options are same. So we can take any option. Okay. So we took 4 and 11. Okay. So for this, now we have one option is 11. That is from this 11. Okay. And then from 4 minus 2 is So 11 minus 3 is 8. Okay, so from this finish to finish. And then from 4 minus 2 is 2, 2 plus 3 is 5. So out of this, we will take this option. Okay, 2 and 5. Okay, and then similarly, it will be 5 and 0. Okay. In this case, everything will be, yeah, I think it should be 5 and 0. Yeah. So from here, it should be 5. 5 minus 5 is 0. And from 2 minus 1, it is 1. And then 1 plus 5 is 6. So we will take this 0 and 0, 5, that option over here. So anytime, in any case, you have to see how many arrows are going into that activity. Okay. So there should be as many number of combinations. So if there are 2 arrows, there will be 2 combinations. If there is 1 arrow, there will be only 1 value. So, okay. So is it clear? I think you should do some more examples like this, and then it will be clear. I will share some of the practice problems later on. Okay. Yeah, please ask any question if it is not clear. Hello?
Yeah,
Do you have any?
Yeah, it would be good to review the backward pass one more time. Just go through it.
Uh-huh. Yeah, so in the backward pass, if you have this activity now, so you can say that there were 4 activities, A, B, C, D. So out of this A, B, C, D, there is now, there were C and D, both were having 11 days. So there is a relationship between C and D. So from C, it was 11. So we will took it as 11 as the latest finish time. So 11 minus 4 is 7. Okay, that is fine. From here, we can go to its preceding activity. So this preceding activity is connected by the finish to finish. So if from the finish to finish, then if it is 11, then its finish should be 11. If it is 11, 11 minus 4, it should be 7 should be 4. From the start to start, if it is 7, 7 minus 3 is 4. I took 4, and 4 plus 7 is 11. So both pairs are 4 and 11 and 4 and 11. So we will took the 4 and 11, and we will take the lowest of those. So lowest of the 2 pairs is 4 and 11, and of course. From C to B, from the finish 11, so it should be 11 over here. Okay, 11 minus 3 is 8. Okay, so it will be 8. From the start to start, it is 4 minus 2, 2 here, and 2 plus 3 is 5. So from 8 and 11, 2 and we will take 2 and 5. This is the lowest of the pair. Okay, this is the lowest of the pair. So we will take 2 and 5. And similarly, we did the same for here, 0, 5 and 1, 6. So we will took the 0, 5. Okay, lower of the values. So in the forward pass, you will take the higher of the values. In the backward pass, you will take the lower of the 2 values. So in this case, now the project, you can also draw this bar chart for that. But you can see that every activity over here is the critical activity. And similarly, in the previous case, it was also critical activities. Is it clear?
Yes, it is. Thanks.
All right. Okay, so I will share some more recorded video about this. So maybe you can also have a look on those videos and then have better understanding. So probably I will give some assignment next week regarding this chapter. And yeah, I wanted to cover some example about the linear scheduling method as well, but that I can do it later. And then in fact, we will also start a new topic as well in the next week. Okay, thank you. So see you next week.
Bye.
Professor,
Thanks.
can I ask?
Yes.